A small crab moves carefully across the reef. Every crack in the rock could hide danger. Fish patrol the open water. Moray eels wait inside dark crevices. For millions of years, survival has depended on one simple rule: stay away from predators. The crab finally reaches a narrow gap in the reef. It's too small for almost anything to follow. It should be safe. Then, no chase, no struggle, no warning, just gone. The predator wasn't faster. It was already there. An octopus. At first glance, it doesn't seem built for survival. It has no bones, no protective shell, no claws, and no teeth. Its body is little more than soft muscle. In the ocean, that should be a death sentence. Yet octopuses have survived for more than 300 million years, outlasting countless predators that once ruled the seas. How? The answer begins with the only hard part of an octopus's body: a sharp, parrot-like beak hidden where its 8 arms meet. As long as that beak can fit through an opening, the rest of the body can follow. An octopus can squeeze through cracks barely wider than its own eye, reaching places no shark, eel, or crab could ever escape. Its greatest weakness has become one of its greatest advantages. But fitting into impossible spaces isn't what makes the octopus one of the ocean's most successful hunters. Researchers studying octopuses discovered something even harder to believe. Sometimes they lost sight of them, not because the animals swam away, not because they hid behind a rock, but because they vanished, while remaining in the exact same place. To most predators, hiding means staying out of sight. An octopus does something very different. It hides in plain sight. Its skin contains thousands of specialized pigment cells that can expand and contract in an instant, changing not only its color, but also its pattern. Other cells reflect light, while tiny muscles raise the skin into bumps and ridges, allowing it to resemble coral, algae, or rough stone. The transformation happens so quickly that researchers have watched octopuses disappear between one video frame and the next. Even after reviewing the footage, they struggle to spot the animal. Camouflage alone would already make the octopus an extraordinary hunter. But for some species, it isn't enough. In the shallow waters of Indonesia lives the mimic octopus. Instead of blending into the background, it becomes something far more dangerous. When threatened, it stretches its arms to resemble the venomous spines of a lionfish. Other times, it tucks 6 arms away and glides across the sand like a flatfish. It can even imitate the movements of a sea snake, discouraging predators that would rather avoid a potentially deadly meal. Rather than relying on a single disguise, it chooses the one that best fits the situation. But perfect camouflage raises an even bigger question. Changing color is one thing. Imitating entirely different animals is another. How can an octopus control 8 flexible arms with such incredible precision while also making complex decisions in the middle of a hunt? The answer lies inside a nervous system unlike almost anything else on Earth. Most animals control their bodies from a single central brain. An octopus doesn't. It has a large brain between its eyes, but nearly 2/3 of its neurons are located inside its arms. Each arm can process information on its own, exploring the environment without waiting for instructions from the central brain. It's less like controlling 8 limbs and more like coordinating 8 intelligent partners. Those arms don't just feel, they taste. Every suction cup is lined with chemical receptors that allow the octopus to sample the water and the surfaces it touches. As it searches through cracks in the reef, it can identify potential prey before it ever sees it. Imagine reaching into a dark box and knowing exactly what's inside just by touching it. That's how an octopus hunts. its intelligence goes even further. In laboratories, octopuses have solved mazes, unscrewed jars to reach food, and learned through observation and experience. In the wild, the veined octopus has even been seen carrying discarded coconut shells across the seafloor. At first, the shells seemed useless, but when danger appears, the octopus quickly assembles them into a protective shelter. It's one of the clearest examples of tool use ever observed in an invertebrate. A flexible body, perfect camouflage, a nervous system unlike almost anything else in the animal kingdom. Each adaptation makes the next one even more powerful. But intelligence alone doesn't catch prey. Eventually, the moment arrives when hiding is no longer enough. The octopus has to strike, and when it does, almost nothing escapes. Unlike sharks, octopuses rarely chase their prey. They wait, completely still. A crab wanders closer. A shrimp searches the sand. Nothing seems unusual. Then, without warning, 8 arms surge forward at once. The prey is surrounded before it can escape. Hundreds of suction cups grip with incredible force, adjusting constantly as the victim struggles. Hidden at the center of those arms is the octopus's only hard weapon, its beak. Shaped like a parrot's, it's powerful enough to crack shells and precise enough to reach the soft tissue inside. Some octopuses have even been observed drilling small holes into shells before delivering a perfectly placed bite. But the beak isn't acting alone. Nearly every octopus species produces venom. Once the bite lands, toxins begin weakening the prey, ending the struggle quickly while reducing the risk of injury to the hunter. One species has taken this adaptation even further. The blue-ringed octopus. Barely larger than a golf ball, it carries tetrodotoxin, one of the most powerful neurotoxins found in nature. Fortunately, it isn't aggressive. Its glowing blue rings are a warning, telling other animals to stay away. A soft body, a powerful beak, venom, intelligence, camouflage. Together, they've created one of the ocean's most successful predators. But no predator rules forever. Even the octopus has enemies. Sharks hunt them. Dolphins do too. Large fish, seals, and even seabirds will seize the opportunity if they can. When escape is no longer possible, the octopus turns to one final defense: ink. It's far more than a dark cloud. The ink blocks a predator's view while also interfering with the chemical signals many marine hunters use to track prey. Those few seconds of confusion are all the octopus needs. By the time the water clears, it's gone, hidden inside a narrow crack where few predators can follow. But perhaps the most extraordinary part of an octopus's life comes after it has stopped hunting altogether. A female lays thousands of eggs inside a sheltered den. For weeks, sometimes months, she guards them constantly, cleaning them and fanning them with oxygen-rich water. During that time, she doesn't hunt. Eventually, she doesn't eat at all. By the time her young hatch, her body has reached the end of its life. Soon after, she dies. Everything she had was invested in the next generation. Remember the crab from the beginning? It believed the narrow crack in the reef would keep it safe. Against almost any other predator, it would have. But the octopus never relied on strength alone. For more than 300 million years, it has survived by solving problems that other predators couldn't. And in the ocean, that may be the greatest advantage of all.